cars moving in the same direction have speeds of 100 km/h and 130 km/h. What is the velocity of the faster car as measured by observer in the slower car? Option A, 130 km/h, B, 230 km/h, C, 200 km/h, and D, 30 km/h. So this is the relative velocity question under physics. Now let's understand this concept. Whenever two objects or two cars moves in the same direction, it is always the faster minus the slower car. Take note of this concept. But when they are moving in opposite direction, it is always the addition of the two speeds. So on the board, the question is moving in the same direction. So relative velocity is equal to the faster car minus the slower car. So the speed of the faster car is given as 130 km/h minus 100 km/h. So we are going to obtain 130 minus 100, which gives 30 km/h. This is when they are moving in the same direction. When moving in opposite direction, it becomes the faster plus the slower. Understand this concept, please. Alright, so let's go back to the option. The correct option on the board is option D, 30 km/h. Let's move on to the next question. Question number 2. A stone and a feather drop from the same height above the Earth's surface. Ignoring air resistance, which of the following is correct? A. The stone and the feather will both reach the ground at the same time. B. The stone would reach the ground first. C. The feather will reach the ground first. And D. The feather will be blown away by the wind while the stone would drop steadily. Alright, let me explain this thing to a proper understanding. Now the question on the board says, assuming there is a stone and a feather, if these two objects are taken to a certain height, be it the height of the pole or that of the tree, even at this state, if allowed to drop on the floor, which of the following is going to occur? What is going to happen? Will the stone get to the ground before the feather, or the feather will get to the ground before the stone, or they will both get to the ground at the same time, or the feather will be blown away, whereas the stone drops steadily? Alright, before answering this question, let us emphasize on the conditional phrase on the board. What is the phrase? Ignoring air resistance. Ignoring air resistance. Now in physics, whenever we say ignoring air resistance, we are actually talking about in a vacuum. What is vacuum? Vacuum is a region where there is absence of air. Please understand this concept. When we say ignoring air resistance, we are talking about absence of air. Everything transfers in the absence of air. Before answering the question or going to the right option, let us state the law of free fall. In physics, the law of free fall states that all objects forced with the same acceleration due to gravity, regardless of their masses, when air resistance is absent. So take note of this, when air resistance is absent. What does that imply? It means that both the feather and the stone are coming from the same height, having the same initial velocity, which is equal to 0, and also the same acceleration due to gravity. That means that since they are having the same height, the same velocity, 0, and acceleration, they are going to get to the ground at the same time. Ignoring air resistance, they will get to the ground at the same time. So the correct option on the board is option A. The stone and the feather would both reach the ground at the same time, ignoring air resistance. So this is the correct option. Question 3. A car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? what is the acceleration of the car? So let us consider the equation of motion that has the relationship between the initial velocity, final velocity, acceleration, and time, because those are the given parameters from the question. First, what are the parameters given? A car moving with an initial velocity, let's say u, is given as 25 meters per second and reaches a velocity of, so the final velocity, let's say v, is given as 45 meters per second, and time is given in seconds. Time t is equal to 10 seconds. What is the acceleration? Acceleration small letter a is equal to unknown. So recall that the equation of motion v is equal to u plus at. So at this point, since acceleration was required, we can actually make a the subject of the formula from here. So acceleration v is equal to v, when this person crosses over, we have minus u is equal to at, dividing the both sides by the coefficient of a, which is t. So t cancels t, and we are left with a. Therefore, we have acceleration a is equal to final minus initial velocity over time. Final minus initial over time. So we are going to use this formula to determine the value for acceleration. So at this point, a is equal to, the final velocity is given as 45 minus the initial velocity is 25 divided by the time 10. So we have 45 minus 25 is 20 divided by 10, which equal to 2 meters per second square. So the correct answer is 2 meters per second square. Question number 4. An object is weighed at different locations on the earth. What would be the right observation? Option A, both the mass and the weight vary. B, the weight is constant while the mass varies. C, the mass is constant while the weight varies. D, both the mass and the weight are constant. So this is basically the comparison between weight and mass. But before this, let us distinguish between the both of them. Mass is the amount of matter in an object. It is basically a scalar quantity. So it is constant. It does not depend on time. So that is mass, and mass remains the same in both Earth, Moon, even space. So it doesn't change. Mass doesn't change. Mass of a body doesn't change. In terms of weight, weight is the gravitational force acting on a mass. Gravitational force acting on a mass. It is a vector quantity. Weight changes with location. Weight changes. So it is never constant. So let us go back to the options on the board. Option A, both the mass and the weight varies. So that is not the right option. Option B, the weight is constant while the mass varies. That is wrong. The weight changes. It doesn't remain constant. So option C, the mass is constant while the weight varies. So the correct option is option C. The mass of a body doesn't change, whereas the weight of a body changes with location. So the correct option is C. Let us move on to question number 5. Question number 5, we have The surfaces of a conveyor belt are made rough so as to dash. Option A, prevent the load from sliding, slipping. Option B, make them stronger. Option C, enable them to carry more loads. And option D, protect them while carrying load. The question is, why are surfaces made rough? Rough surfaces increases friction. What is friction? Friction is the force that prevents sliding or slipping between two surfaces in contact. That is the reason why our car tire or our footwear are made rough. If the belt surface was smooth, the load tends to slide backward. So making the surface rough increases friction between the belt and the load. So it helps to carry the load without slipping. So the correct option is prevent the load from slipping. Prevent the load from slipping, which is option A. Prevent the load from slipping. Question 6. A machine of velocity ratio 6 requires an effort of 400 Newton to raise a load of 800 Newton through 1 meter. Find the efficiency of the machine. Options are given below. So the first thing we must do is to write down the correct parameters from the question given. From the question we have velocity ratio is 6. Velocity ratio, let's say VR is equal to 6. And the next thing given is the effort of 400 Newton. Effort E is equal to 400 Newton. Raise a load of 800 Newton, and the load F is equal to 800 Newton through 1 meter. So the distance moved by load, the distance moved by load is equal to 1 meter. So what is the relationship between these parameters given on the board? The relationship that we can establish between these is the efficiency, and the efficiency E is equal to mechanical advantage divided by velocity ratio. Velocity ratio times 100 times 100 times 100. So mechanical advantage is equal to mechanical advantage MA is equal to load divided by effort. That is the formula for mechanical advantage, and the formula for velocity ratio is the distance moved by effort over distance moved by load. So let us determine the value for mechanical advantage since velocity ratio is given from the question. Mechanical advantage is equals load over effort, and the load was given as 800 Newton divided by the effort, which is 400 Newton. So this gives 2. Efficiency E is equal to mechanical advantage divided by velocity ratio times 100 over here. So the mechanical advantage is 2 divided by velocity ratio. And velocity ratio from the question was given as 6 times 100. So if you multiply this by this, we obtain 200 divided by 6. This gives 3.3%. So the correct option on the board is Option C, 33.3%. Let's go to the next question, question number 7. If a wire 30 centimeters long is extended to 30.5 centimeters by a force of 300 Newton, find the strain energy of the wire. Find the strain energy of the wire. So whenever we come across a calculation problem, the first thing we must do is to bring out the parameters from the question given. So from the question we have the length of a wire is 300, original length of wire equal to 30 centimeters, and the extended length of the wire is equal to 30.5 centimeters. The force given, is equal to 300 Newton. Then we are required to determine the strain energy. The strain energy is unknown. So the first thing we must do after bringing out the parameters is to find the extension. So extension equal to change in length, which is equal to the extended length minus the original length of the wire. So extension is equal to, the extended length was given as 30.5 minus 30.0. This is in centimeter. So this is equal to 0.5 centimeters. Next thing is to convert this result. This is for extension, is to convert the extension from centimeter to meter. Don't do this mistake. Always ensure you convert from centimeter to the right unit. Conversion standard, 100 centimeters is equivalent to 1 meter. So 0.5 centimeters is going to yield, let's say, x. If you cross and multiply, it becomes 100x is equal to 0.5 times 1, 0.5, and x gives 0.5 divided by 100, which equals 0.005 in meter. This is in meter. So we are using this. This is for the extension. Extension equals 0.05, which is equal to 0.005. So extension now, from the conversion standard, extension is equal to, converted to 0.005 in meter. Question on the board is find the strain energy. To find the strain energy, we have to apply the formula for strength energy. Strength energy, the strain energy is equal to 1/2 times force times extension. 1/2 times force times extension. So strain energy, the strain energy is equal to 1/2 times the force. Force was given as 300 Newton times, first was given as 300 Newton times the extension, and extension is 0.005 in meters. So 0.005 meters. If you calculate this, you are going to have 1 times 300 times 0.005 divided by 2. So this will yield 0.75 joules. So the correct option on the board is option D, 0.75 joules. Let's move on to the next question. Question number 8. Hydrometer is an instrument used in measuring dash. Option A, density of liquid. Option B, relative density of a liquid. Option C, relative humidity of a liquid. And option D, vapor pressure of a liquid. Hydrometer measures how dense liquid is compared to water. How dense liquid is compared to water. Let us examine the options. Option A, density of liquid. Density of liquid is measured by mass and volume. So option A is not the right option. Option B, relative density of liquid. The relative density of liquid is measured by a hydrometer. Let's look at option C. Option C, relative humidity of liquid. This relative humidity of a liquid is measured by a hygrometer. So take note of this. Between the option A and the option B, the correct option is B. But there is a similar instrument compared to that of B. This person is hydrometer for relative density of liquid, while relative humidity of liquid uses a hygrometer. So take note of this. But the right option is option B, hygrometer, used by relative density of liquid. And the option D, vapor pressure of a fluid, uses pressure instrument. So take note. Pressure instrument, hygrometer, mass and volume. Question 9. The density of a certain oil on frying becomes 0.4 kg per meter cube. With a volume of 20 meter cube, what will be its initial volume when its initial density is 0.8 kg per meter cube? Assuming no loss of oil spillage. So in the option we have A, 10 kg per meter cube, B, 5 kg per meter cube, C, 8, and D, 12 kg. When oil is heated, it expands and the density decreases. So from the question, assuming no loss of oil spillage. So at this point, there's no loss of oil. And since there's no loss of oil, the mass remains constant. So the formula for density P is equal to mass N divided by volume, mass over volume. So this is the symbol for density, which is rho. It is called rho. So according to the question, there are two different containers, the container before heating and after heating. So since the mass is constant because there's no loss in oil, we can make M the subject. Mass M is equal to rho, which is density times volume. Density times volume. Because there are two different containers before and after heating, we can say that P1V1 is equal to P2V2. So this P is called rho and V is the volume. This is the density before heating, whereas this is the density after heating. So let us go back to the board and pick the correct parameters. In the parameters, we have initial density is 0.8 kilogram per meter cube. Therefore, P1 is equal to 0.8 kilogram per meter cube. And P2 is equal to 0.4 kilogram per meter cube. Then V1 from the question is what is required. What would be its initial volume? So V1 is unknown and V2 is equal to, from the question, V2 is given as 20 meter cube. 20 meter cube. From the formula we have P1 V1 equal to P2 V2. So making V1 the subject from here, if you make V1 the subject, okay, let us do that. P1 V1 is equal to P2 V2. Dividing the both sides by the coefficient of V1. So by P1, so this cancels this, and we are left with V1 is equal to P2 V2 all over P1. So at this point, we can substitute the values into this. So fixing the value into the formula, we have that V1, which is the initial volume, equal to P2 times V2. P2 is 0.4 times V2 is given as 20 divided by P1, and P1 is given as 0.8. So multiplying this by this, we obtain 10 meter cube. So the volume on the board, so the volume is 10 meter cube, and the correct option on the board is option A. Then we are required to determine the volume, the initial volume, and not the density. So since we are obtaining 10 meter cube, there was an error in the question. So the unit is supposed to be in meter cube, not in kilogram per meter cube. So it is in meter cube. So the correct option is option A, 10 meter cube. The small droplet of water that forms on the grass in the early morning or early hour of the morning is dash. Option A, we have dew. Option B, mist. Option C, fog. And option D, hail. So let us start with the last option D. What is hail? Hail is the ice ball that drops during thunderstorm. The ice ball that drops during thunderstorm. So that is not the option. While fog is the thick cloud near the ground. The thick cloud near the ground. So the next option is mist, which is the tiny water droplet that is suspended on the air but not on the ground. So the correct option is option A, which is dew. Is the small drop of water that forms on the grass or on the surfaces or even on your flower in the early morning. So the correct option is option A, dew.